Hi guys, this is IGCSE O-Level Chemistry, paper 22, June 2018, question 11. Dilute sulfuric acid is electrolyzed using inert electrodes. What are the ionic half equations for the reaction that take place at each electrode? So the positive electrode is the anode, and anode is where oxygen gas will be produced. The negative electrode is the cathode, and cathode is where hydrogen gas will be produced. So this eliminates options A and B. So anode is where oxidation occurs, so there will be loss of electrons, and the equation would be 4 moles of OH negative ions producing 2 moles of water, releasing 1 mole of oxygen gas, and 4 moles of electrons are lost. So this eliminates option D. And at the cathode, we would have 2 moles of H positive ions accepting 2 moles of electrons, producing 1 mole of hydrogen gas. Therefore, option C is the correct option for this question. Question 12. Which diagram is a correctly labeled energy level diagram for an endothermic reaction? So for endothermic reaction, the energy of the product is greater than the energy of the reactants, which automatically eliminates options C and D, which are exothermic energy profile diagram. So between A and B, now the activation energy is the energy from the reactants till the maximum energy state, and that is stated in option A. In option B, overall energy change is stated, which is incorrect. The overall energy change is the energy change between the reactants and products, which is correct in option A, and incorrectly stated as activation energy in option B, eliminating option B and making option A the correct option for this question. Question 13. The equation for the complete combustion of methane is shown. The bond energies are shown in the table. What is the energy change for this reaction? So bonds of the reactants are broken and bonds of the products are formed. The bonds of the reactants include 4 carbon-hydrogen single bonds and 2 oxygen-oxygen double bonds. And for the products, we've got 2 carbon-oxygen double bonds and 4 oxygen-hydrogen single bonds. So the bonds of the reactants which are broken would have an energy change of 4 into 410 plus 2 into 496. This would be the energy required to break the bonds. And we subtract from this the energy given off when bonds are formed. So the bond formation includes 2C double bond O, so 2 into 805, and also 4 OH bonds, so 4 into 460. So when we calculate this, we end up with a value of minus 818 kilojoules per mole, which makes option A the correct option for this question. Question 14. Which row describes the effects of increasing both concentration and temperature of the collisions between reactant particles? So increasing concentration would cause more collisions per second only? Yes, because more number of reactants would be present. Next, more collisions per second and more collisions with sufficient energy to react? No, there is no increase in energy, so this is incorrect. More collisions per second only is correct. More collisions per second and more collisions with sufficient energy is incorrect. So, increasing the temperature. Increasing the temperature will increase the number of collisions, and also it would increase the number of collisions with sufficient energy, because temperature is directly proportional to the kinetic energy possessed by the molecules. So an increase in temperature would mean a gain in energy. A gain in energy would mean that more molecules would have sufficient energy to react. So this eliminates options A, B, and D, making option C the correct option for this question. Question 15. Sulfur dioxide reacts with oxygen at 2 atmospheres pressure. The forward reaction is exothermic. The equation for the reaction is shown. The reaction reaches equilibrium, the pressure is then doubled. How and why does the amount of sulfur dioxide formed change? So if the pressure is doubled, the increase in pressure favors the side with the lesser number of moles. So in this equilibrium, the number of moles of reactants is 3 and the number of moles of products is 2. So an increase in pressure will favor the forward reaction. So the amount of sulfur trioxide would increase, eliminating options A and B. And the reason for this is C says the forward reaction is exothermic, and D says there are fewer molecules on the right. So the forward reaction is exothermic, has nothing to do with an increase in pressure, but fewer molecules on the right is the reason why the equilibrium shift towards the right, making option D the correct option for this question. Question 16. Iron 2 chloride solution reacts with chlorine gas. The equation is shown. Which statement about this reaction are correct? Fe2 plus ions are reduced to Fe3 plus ion. If there is a gain in an oxidation number, that is oxidation, not reduction. So this statement is incorrect. Chlorine acts as a reducing agent. Chlorine is reduced to chloride ions. So a reducing agent gets oxidized, not reduced. Since chlorine is getting reduced, chlorine is acting as an oxidizing agent. The statement 2 is incorrect as well. Fe2 plus ions each lose an electron. Yes, because it is converted into Fe3 plus ions. So this statement is correct. And Cl2 molecules are reduced to chloride ions. Yes, that is what happens during this reaction. So statement 4 is also correct. Since statements 3 and 4 are correct, option D is the correct option for this question. Question 17. Which statement about oxides is correct? A solution of magnesium oxide has a pH less than 7. Magnesium oxide is basic in nature. It would have a pH greater than 7. So this is incorrect. A solution of sulfur dioxide has a pH greater than 7. Sulfur dioxide is an acidic gas. So when it dissolves in water, it would form a solution with a pH of less than 7. Magnesium oxide reacts with nitric acid to make a salt. Yes. And a base would react with an acid to make a salt. Sulfur dioxide reacts with hydrochloric acid to make a salt. Both are acids, they will not react. Therefore, the correct option for this question is option C. Question 18. Which statement about acids and bases is correct? A base is a donor of hydrogen ions. No, a base is an acceptor of H positive ions. An acid is an acceptor of H positive ions. No, it is a donor of H positive ions. A strong acid is fully ionized in aqueous solution. Yes, that is the definition of a strong acid. A weak acid cannot be used to neutralize a strong base. Yes, it can. Only the quantity required would be greater if the concentration is less. So the correct option for this question is option C. Question 19. The solubility of some salts is shown. Barium has a soluble chloride, a soluble nitrate, an insoluble sulfate, and an insoluble carbonate. Lead has an insoluble chloride, a soluble nitrate, an insoluble sulfate, and an insoluble carbonate. Potassium has all soluble salts. Zinc has only an insoluble carbonate. Rest of the salts are soluble in case of zinc. Which two aqueous solutions produce an insoluble salt when mixed together? So those two solutions will have to be soluble on their own. So barium chloride and zinc nitrate would produce barium nitrate and zinc chloride, both of which are soluble. Barium nitrate and lead nitrate would not react because the anions are the same. So both of them would remain soluble. Lead 2 nitrate and potassium carbonate would react to form potassium nitrate and lead carbonate. Lead carbonate is an insoluble salt, so we have production of an insoluble salt when these two solutions are mixed together. And potassium nitrate and zinc sulfate would form potassium sulfate and zinc nitrate, both of which are soluble, so no formation of an insoluble salt. So this makes option C the correct option for this question. Question 20. Which methods are suitable for preparing both zinc sulfate and copper 2 sulfate? Reacting metal oxide with warm dilute aqueous sulfuric acid? Yes. Zinc oxide would react to form zinc sulfate and copper oxide would react to form copper sulfate. This is correct. Reacting metal with dilute sulfuric acid, zinc would react to form zinc sulfate, copper would not react with sulfuric acid because copper is less reactive than hydrogen. So this is incorrect. Reacting the metal carbonate with dilute aqueous sulfuric acid, zinc carbonate would react to form zinc sulfate and copper carbonate would react to form copper sulfate. So this is correct as well. Since methods 1 and 3 are correct, option C is the correct option for this question.